In my next video lecture, I'm concentrating on the manufacturing process of monolithic IC. So this manufacturing process of monolithic IC comes under the linear integrated circuit subject. So in this today I'm going to say what are the processing preparing steps for the integrated circuit. So here this word monolithic is from the Greek word. It has been derived from the Greek word, says that one stone. Monolithic means one stone. So what we are doing here means a monolithic IC is being taken, okay, in which all the circuit components and their interconnections are formed on a single waveform, which is known as a substrate, which is called as a substrate. A monolithic IC, this one, on the single stone, we are going to interconnect all the circuit connections, okay, which are formed on a single waveform. That is known as a substrate. Now let's come to some steps involved in preparation of or manufacturing of integrated circuit. So the first step is preparation of silicon waveform. Okay, so here have been considered a p-type crystal, silicon crystal, which will be cutting into some thin wafers, okay, by using the diamond. So around like a dimension of 200 micrometers thickness, the wafer has been cutted and been considered a separate. Means now based on that one wafer, I'm going to manufacture the integrated circuit. So here in the first step, we have been prepared a silicon wafer of p-type. So in a circuit connections, next in the manufacturing process, next we are going for growing the epitaxial n-type layer. Means epitaxial here means it's referred to a type of crystal growth. So what type of crystal growth I'm going to done here means I'm going to have an n-type. So now on the p substrate, I've been taken around like 10 micrometers of n-type layer. So this n-type has been grown on the p substrate. So finally we can say that there is a formation of PN substrate. There is a formation of PN substrate. So based on this, what happens? This has been done. This has been grown of epitaxial layer has been done that this wafer, whatever is there, right? So this wafer is placed in a high temperature, or we can say like a furnace. So there what happens? Different gases produce this n-type growth, which are being introduced in the furnace. Means whenever the temperature has been, we have placed in that temperature, the gases which has been produced this n-type growth on the p substrate. So resultant what happens? The PN wafer or a PN substrate has been formed. Okay, so coming to the third step, the coating with the silicon dioxide. It means that in the first two steps we have been formed the P and N. Now coming to the third step with the in order to prevent some contamination. What is meant by contamination? Like poisoning or polluting. So for that what we are doing? Yes, we are growing some silicon dioxide layer on this PN substrate. Completely this PN substrate, I'm going to pour the 1 micrometer of the silicon dioxide layer. Okay, means that this has been achieved like that. The oxygen means we have to pour a complete oxygen layer on the epitaxial layer. So this oxygen, nothing but silicon oxygen atoms, will be combined with the silicon atoms, producing as SiO2. Okay, so in the first three steps, firstly the crystal has been cut into some thin wafers. So in that single wafer has been grown with an epitaxial n-type layer, and then a silicon dioxide layer has been grown or been coated on PN substrate to overcome or to prevent the contamination. Okay, coming to the next step here, the next step is etching. So here etching is nothing but removing. Etching means nothing but removing. So before any impurities been added to the substrate, the silicon dioxide layer has been removed. Means I want to add some components, some impurities here. So I'm going to remove the silicon dioxide layer. So the process of removing the silicon dioxide or the epitaxial layer, the process of removing the epitaxial layer at desired locations and diffuse the wanted materials to produce desired components is known as the etching. Means here what we are doing means we are removing the silicon dioxide. Why it is required, why we want to remove that means to have a desired locations. Means I want to diffuse some metals, okay, I want to diffuse some materials, okay. So why I want to diffuse means I want to produce some components there. So for that purposes we are required the etching. Okay, so short and sweetly we can say that etching is nothing but it's a process of removing. It's a process of removing. Why it is being used, why we want to remove the silicon dioxide layer means to diffuse some wanted materials. To diffuse some wanted materials. Why? To produce some desired components. For that purposes we are going to have the etching. So the first 4 steps, again I am repeating that the silicon wafer has been considered from the crystal, and then N-type epitaxial layer has been produced. On the top of that we have given the silicon dioxide layer, and then we have been removed some part of silicon dioxide layer because of some making some desired components to be diffused on that. And the next one is the isolation diffusion. So as I said that this silicon dioxide has been removed some in a desired locations, okay, in a wanted locations. So in that what happens, some part has been cutted. Let us think like that. So here what happens, to produce some different components, okay, so each components required one N well. So nothing but N. Why? Because this is a P substrate, so some parts required N well. So for the purpose of isolation of components, this will be done by the isolation diffusion. Means that this part has been window cut into oxide layer is permitting to diffuse the p-type. Means N well is there, and beside the P plus ions, saying that there is a combination of Pn, we can say that. Okay, so what happens, a p-type will be diffuses through the epitaxial layer, n-type layer, and this makes like a NPN and PN diodes, right? So if you observe here, it is a combination of one diode, here is a one combination of another diode. I can take this as a this is P substrate itself. Means there is a formation of NP and PN diode. So this overall isolation diffusion is for the producing the components. What type of components we can have? Yes, we can have a diodes, we can have a resistors, we can have a transistors, or we can have a capacitor. So to produce all these electronic components, they require of a isolation diffusion. And the last one, that is cutting the chip and packing. So whatever the process has been done, it has been cut into small pieces. Okay, so this is one IC, this is another IC, this is another IC. So these all has been cutted, and one particular part can be packed over. So like that, these are the processing steps for the integrated IC. Thank you.